Alright. Hi guys. Thanks for coming back from the break. I'll try not to bore you too much. My name is Earle Philhower. I'm in the technical marketing group at Western Digital, HGST division. And today I'd like to talk to you a little bit about the S3 connector and how it's used with our product, the Active Archive here. So, without further ado, I'm going to say hi. I'm going to tell you a little bit about HGST, and I'll try not to bore you too much. I'm new here. HGST is new here, but HGST itself is not new whatsoever. It's been around for well longer than my lifetime. Talk to you quickly about what object storage is and how it's different from file store and why this is important to you. How you can use the S3 connector to put things together. So basically, how you can bolt this big box of storage into your iRODS system and actually use it basically seamlessly. I'll talk a little bit about the changes we did to the S3 connector, and we've committed back to the project. And I like showing graphs. I'm in tech marketing, so I like numbers and pretty graphs when things go up. So I'll show you as things go up versus the old time, and talk quickly about what I'd like to see maybe happen in the future with the S3 connector, what we're looking at, how we're going to work together with the iRODS. So HGST, we've been around since 1956. I'm not going to bore you by reading up everything we provide, but if it stores data, we pretty much build it. SSDs, hard disk drives. We have some software. We also have something called the Active Archive, which is a massive object storage system of scales to petabytes. And you probably have seen Western Digital in the news recently. We just finally acquired, closed on the SanDisk deal. SanDisk, the SSDs powered probably half your laptops around there. So why should you stay awake for the next 10 minutes? That's a good question. Well, this product, or Active Archive with S3 interface, basically lets you add multiple petabytes of storage to an existing iRODS system. Almost push-button easy. You don't have to worry about things like managing your own storage arrays or your own white boxes, building things up. This is a storage product. We start with about 600, 700 terabytes to begin with. We can scale up to 30 petabytes in a multi-installation, multi-geographic system. And we provide kind of that capability without the difficulty of rolling your own. What this can let you do with your existing iRODS, you probably have your iRODS running on some fast file system, which is great. But it's also probably a lot more expensive per byte than what we're proposing here. So you can migrate your data thanks to iRODS rules, on last usage, on project basis. As things roll off, instead of deleting them or putting them on a spot on your NAS, you can put it on us. It'll still be completely available thanks to the magic of iRODS. It'll just be costing you a lot less to keep things going. And beyond that, this is an archive, so things like data reliability, data retention are first and foremost. We use erasure coding to guarantee about 15 nines. That's 99.99. A whole lot of nines there. As well as things like synchronous geo-replication or geo-distribution of data. So if you have a multiple site system and San Francisco falls off the map because of the big one happens, you can still get all of your data off of your Los Angeles and your Las Vegas data centers. Basically, even without interruption, other than people screaming and yelling, saying San Francisco is falling off the map. That was a joke. All right, so 60 seconds object storage. I'll try to do it in a little less than that, so we have get to do this stuff. But object storage is not POSIX storage, and that's really why we have this S3 connector. That's why people have to rewrite their applications a lot of times to use this kind of technology. Things are immutable. That means you can't do a file update. You can't do a partial write. You can't rename even a file or an object. It's just not possible. But this this capability, or these restrictions, grant other capabilities. Basically, because we are doing this in a non-POSIX way, we can do a RESTful web interface, so things like your load balancer and your traffic monitors all work directly with it. We can do erasure encoding behind the scenes, which gives you better data durability at a lower storage cost, because we can actually do things that RAID can't behind the scenes to get higher reliability with less amounts of storage, less amounts of disk, less amount of replicates. And you don't want to know what the RAID rebuild time on a RAID 6 or a 10 terabyte hard drives is. It's not very fast. Beyond that, because it's not a file system, you don't have to worry about partitioning it up into multiple silos of millions of files, because things start falling over in file systems when you start having millions of files. We can have billions of objects because it's not a file system. Because of this immutability, we can actually work behind the scenes to make it a lot simpler to use, a lot easier. All right, so this is the marketing slide, I'm sorry. So this is the complete scale-up and scale-out storage system. Really the key here is it's a product that comes as a rack to your data center. The entire setup involves simply specifying an IP and an administrator login and plugging the darn thing into your network. We go from anywhere from about 700 terabytes raw to 5 petabytes, 6 petabytes in a single rack, and we can actually expand to 6 racks at multiple sites, connected by WAN links for synchronous geo-distribution data. The key here is simplicity, right? So you can build this your own, probably if you dedicate hundreds of man hours per week and you have a whole lot of hardware that is sitting around, but it's not going to be nearly as reliable, it's not going to be nearly as easy. One of the key neat features here is a new geographic spreading of data. So every object is synchronously spread amongst multiple sites. So if you do have a 3GEO installation or a 3 geographic area installation, data is actually always synchronously available. Data is not marked as written until it's available at all the other sites. And really that's the key here. So how do you use this with iRODS and the meat of the talk here? So the S3 connector works through something known as a compound resource. The folks in the advanced class from yesterday have already heard about this, but basically a compound resource merges a POSIX type file system with an archive time file system. So in this case, the object file system would be the active archive or any other S3 interface guide. And the POSIX would be a local cache. Now this could be an SSD or a DRAM cache. If you're using synchronous replication, otherwise obviously you need a stable store. The key here is it's seamless to end users. You have a resource that people write to or that files are directed to via iRODS rules, and things just happen behind the scenes to make sure it's replicated or pushed into the active archive on time. Really the key here is, again, this cache takes care of all the POSIX stuff and kind of gets rid of the problems of having a RESTful interface, an object interface for your end user, so they don't have to actually rewrite their own apps. Now the upgraded S3 connector, there was an S3 connector there before in the 4.x series, maybe even the 3.x, but it really wasn't enterprise class, to be frank. It worked, it did not work with very large files, it had issues with performance and scalability and maybe things that you care about, like checksumming of data and things like that. That just wasn't there. But we have a new version. It's just been merged actually by Antoine, if he's around. Thank you. Many, many months, but it's in there. And the key here is, I'm from the HGST talking about the active archive, but the changes here work for all your S3 interfaces. So if you got an S3, if you're talking to Amazon, if you're talking to your own object store or Ceph or something of that via S3, it'll work too. But the key options here are speed and reliability. By using multi-part, and parallel operations, just like iRODS does with iPut, we can access your archive at multiples, 10, 20 times faster than possible before. I've got some graphs at the end I'll go through quickly. The other key is reliability. So things like MD5 checksumming, the data wasn't there, that's available now. Things like the server-side encryption, which may be a requirement depending upon the data sets you're using. Things like that are now optimized and available. Now, how would this be used in, say, a multi-site installation with iRODS? It's not a lot different from what you're exposed to today with sort of a federated iRODS installations. You will have multiple sites, and each site is talking to this one active archive via the resource servers. These resource servers also talk to this one global namespace. That's kind of why everything there is in that one little blue box there. They're physically 3 different locations, but they're logically it's one namespace and an object existing in one exists in all. There's no idea of, oh, it exists only in San Francisco or Zurich. It exists everywhere as long as these archives are connected. And users access it through iRODS with iPut, iGet, the Fuse file system. Things just magically work behind the scenes thanks to the magic of the rules engine. And beyond that, for folks that are supporting users that have S3 aware applications today, because we store data in an unencrypted, unmodified form, object equals file in this case, which is not necessarily the case for some object stores or some ways of storing data inside these object stores. Native S3 applications, like if you're migrating from AWS, can seamlessly access this data. And in a read-only mode, obviously. If you start writing to data, iRODS will not know about it. But things like scanning pre-existing data can be done seamlessly without changes to the applications. Now, I'm going to talk really fast on some of the tests we were doing. So I was talking, theoretically, this is what I would have loved to test it, but they wouldn't let me go to Zurich and Amsterdam and places like that. So I just had to work in my one lab with a single box, locally 10 gig networking, nothing fancy. I mean, these are on the motherboards today. Single node iRODS installation was 4.18, but there's no material differences. Now, the key here is, I was talking about early on, the existing S3 connector is functional but slow. If you look at the single guy here, these are the performance, the single-threaded performance of writing and reading from an archive. Your S3 was probably around that number too, even if you were talking to Amazon. By using the same kind of technology that iRODS is using for the parallel put, but doing it in the S3 method, we're able to pull that over 2 gigabytes a second. So 20x improvement with no modifications really to the end user. He just does an iPut or an iGet. Instead of going at 100 megabytes a second and taking 5 hours, it goes at 2 gigabytes a second and takes a few minutes. Really, that's the magic behind the scenes. This is fully documented. We have sane defaults right now. Your performance is going to vary. If you're running against Amazon S3 on a 100 megabit link, don't expect to see 2 gigabytes in. But you will be seeing some other performance enhancements and stability enhancements. Just due to the fact that we can do multi-part operations. So if a little bit fails, you're not going to have to re-upload a large file. So there was some future work, which thankfully it sounds like is actually already being done. Yes?
Yeah. When you showed the picture of your test bed,
that's my test bed, yes.
You had a 210 gig link. Is that the saturation point for you?
Well, that is, for the active archive itself, no. A single box will go...
iRODS to active, because I see you're saturating it.
Well, I only had 2 links on the box.
Okay. Yeah.
So it was, honestly, it was about 4 cores out of 24 were being pegged, but because I only had a dual 10 gig link, that was where it was at. If we had a quad 10 gig, I'd expect to see around 3.5 gigabytes.
Exactly, that's what I was thinking. So you're saturating.
Yeah, I'm saturating with the network.
Okay.
Yeah, in this case, it's network saturated.
Okay.
But you can have multiple resource servers. So you can actually get full bandwidth of that right-hand side to your users. Future work, it's already actually being done by Antoine, the V4 authentication, which I know some folks require for some of the European AWS services. The other part is these caching mechanisms. Right now you have to manage your own cache, you have to write your own rules, and they're not terribly easy to do. I'd love to figure out how we can maybe use a pluggable rules engine or even modify the compound resource to make a smarter cache. So, I've got exactly -1 minute for questions. Yes, sir.
Negative question. So,
I'm positive, so let's make them positive.
your picture with the London Zurich Amsterdam, is that like?
Yes, I did.
Interested how you propagate there? Is that active passive mode or?
So everybody is active in this situation. So these are just, I don't know where they came up with the iconography. These are just network. So think of these as the storage boxes. So 1, 2, 3, 4, 5, 6 archives. They are synchronously connected over WAN links between them. There's one global namespace between these guys of, I don't know, 30 petabytes raw at this point. Does that answer your question, or?
No.
All right.
So the question was basically, in your picture there was more than one, because you wanted to prove the failover with one side, you would still be able to.
Oh,
so the question was, how do you keep two ICAs in sync, two or more ICAs in sync?
So the ICATs, you have multiple ways of doing that, and that's kind of orthogonal to this. The ICAT is based on the database, right? ICAT itself is stateless, so as long as you can make your database highly available and redundant between these sites.
Implemented by you, so that's left behind.
Yep. Well, you're doing that anyway, I hope, because you're going to have a high availability ICAT database behind the scenes. But yeah, this doesn't really affect that. The resource server itself would be highly available because the underlying storage is highly available. All right, nothing else? Thank you, folks.